Welcome to The Click. Today we will be learning repeating decimals and fractions conversion alongside rounding off. So let's get started. The learning targets of today's lesson is learning pure repeating decimals and fractions conversion, learning mixed repeating decimals and fractions conversion, alongside learning round off. But before starting, I actually wanted to make pure repeating decimals and mixed repeating decimals clear for you so that you don't have any problem during the lesson. Pure repeating decimals. At the beginning, what are decimals? We know what decimals are, right? Decimals are the numbers that have two parts, and they are separated by the decimal point, right? So they have two parts like this number. 12.21. 21 is the decimal part, 12 is the whole number part, right? So these are decimals. Repeating decimals, what are they? Repeating decimals are the decimal numbers that are repeated, and we know what repeating numbers are. Repeating numbers are, for example, like this, like 3.12, and 12 is repeating, right? So they're repeated, so they are going to be repeated in the decimal part. Or if they're whole number, repeating numbers are the ones that get that line, this line over them, and we know that whenever we see this line, we know that they're going to be repeated. So these are repeating decimals, right? And what is pure repeating decimals and mixed repeating decimals? What are they? So we have two types of repeating decimals, pure and mixed. Pure is when all decimal digits are repeated, but mixed is when some decimal digits are not repeated and some are. So for example, guess what? This is, it has two decimal digits and both of them are repeated. So this is a pure repeating decimal, right? But what about this one? 3.12 and 2 only being repeated. This is mixed repeating decimal, right? So yeah, this was all about repeating numbers and decimals and types of them. So now let's get started. Repeating decimals and fractions conversion. So we can convert repeating decimals, whether they're pure or mixed, to fractions. How can we do that? We first subtract the whole number from the number containing repeating digits and write the result as the numerator. So we subtract the whole number part from the number containing repeating digits, or all the digits, no matter if they're decimal, no matter if they're whole, no matter if they're repeating, all of them combined. Then we subtract that by the whole number part, and then we write the result as the numerator. And then in the denominator, we write as many nines as there are repeating digits. Okay, so instead of repeating digits, we write 9. As many of them there are, we write 9 instead of them in the denominator part. And then yeah, that's basically our fraction. So let's go with the first example. 356.8912. So we have 8912, they're repeated and decimal digits at the same time. So we say that we should subtract the whole number part from all the digits. So all our digits are 3568912, and I should subtract this number by the whole number part, which is 356, right? So this is let me make it clear for you. So whole number part is this, and repeating alongside decimal part is that. So this is whole number, right? And these are all the numbers together, so they're combined. So I use the color blue for this, right? So it's both 3,568,912 subtracted by 356. So 2 minus 6, we cannot do that, so we might be in depth again. 0, 12, 12 minus 6, 6. I'm gonna borrow another number. 8, 10, 10 divided by 5, 5, 8 divided by, not divided by, I'm sorry, 8 minus 3, 5, and then these are remaining the same. So we have 3,568,556 this time. And let me separate them by this symbol. And yeah, this is our answer. So this will be our, guess what? Our numerator, exactly. So 3 million. Okay, so this is our numerator. Okay, now in the denominator, how many repeating digits do I have? I have 4. 8, 9, 1, 2. There are 4 numbers, right? 4 digits. So I write 4 nines in here. And this is the fraction part, or the fraction version of this number. Right? Did you get it? So let's go with another example, a simpler one. 28.65. So we do the same part, the same process for this one as well. We write all the digits and then we subtract them by the whole number part. 6, 5, subtracted by 28. So 5 minus 8, I borrow a number from 6. This becomes 15, 8, 9, 10, 11, 12, 13, 14, 15, 7, 5 minus 2, 3, 8, 2, 2,837, right? So yeah, this is our answer. So this will be our numerator, 37 divided by 9, because we have 2 repeated digits, and this is our answer. Okay, this was the first part. Now let's go for mixed repeating decimals and fractions conversion. We basically do literally the same thing, and then we only add zeros in front of, or on the right side of the nines in the denominator, as many zeros as the digits of non-repeated decimals. Okay, so let's go with an example. I go with the same process for this one as well. 7987 subtracted by the non-repeating part, which is 2379. Okay, so let's do the subtraction quickly. This is our numerator. Okay, so this is a 0. So 2, 3, 5, 6, 0, 8, separating them. And then in the denominator part, we write nines for the repeating digits and zeros on the right side of the nines for the non-repeating digits, decimal digits, right? So we have 2 repeating digits and 2 non-repeating digits. So for repeating digits, I write 9, 2 repeating digits, 9, 9, and then 2 non-repeating digits, so 0, 0 on the right side of 9, right? And this is our answer. Okay, so yeah, you basically go and subtract the non-repeating part from the from all the digits, and then we write that in the numerator. In the denominator, we write nines for repeating digits and zeros for the non-repeating digits. And about this one, 56.897. So we have 1 repeating digit and 2 non-repeating digits. So let's go and do the subtraction at the beginning. 897 divided by 5,689. Okay, I'm going to do the subtraction quickly. Okay, so 51,208, 51,208, and then in the denominator I will write 1 9 and 2 zeros. And this was mixed repeating decimals to fractions conversion. Okay, now we will go for the last part and the second part, which is round off. Okay, so rounding decimal numbers, what does it mean? Rounding means making a number simpler by reducing its digits. So we might have so many decimal digits and we try to make it simpler by reducing the digits. And that is basically called rounding or rounding off. There are two types of round off, which are round down, which the result is smaller, and round up, and which the result is bigger. So this is what rounding is, and how to do rounding, how to do round off. When rounding, e.g. to 2 decimal places, so for example, we want to reduce the digits of decimals to 2, okay? 2 digits we want, not more. So in that time, we go and take a look at the next digit. What is the next digit? The third digit, right? Because we want to have 2 digits, so the next digit after 2 is 3, right? So the third digit, we look at that. If it's less than 5, we keep the digit the same. We keep the second digit the same. If the third digit is greater than 5, okay, we add 1 to the second digit. But what about if the third digit is 5? At that time, what should we do? At that time, we take a look back at the second digit. If the second digit is odd, we add 1. If the second digit is even, we keep it the same. Just wanted to add a quick note. If more digits follow after 5, like 4 or 5 digits, then add 1 to the second digit. But if nothing follows after 5, you take a look at the second digit. If it's odd, 1, add 1. If it's even, keep it the same. This might feel very, very complicated, but it's so simple. And round off is basically a very simple concept just to reduce the digits of decimals. Take a look at this. 8.659. In here, I want this has 3 decimal digits, right? So I want it to have 2 decimal digits, 65, okay? But should I just remove 9 and not consider it anyway? No, that's completely wrong. So what should I do? I take a look at the third digit. If it's greater than 5, I add 1 to the second digit. Okay, so it's greater than 5. 9 is greater than 5. So I add 1 to 5, which is the second digit, right? And this will be 8.66. Did you get it? Okay, this one, 56.9823. Okay, so my second digit, I want to have 9, 8, but I cannot just remove 2 and 3. So I will take a look at 2, which is my third digit. 2, oh, okay, 2 is smaller than 5. So I know that if it's smaller than 5, I should just keep the second digit the same. So yeah, because it's smaller than 5, 2, the third digit, I keep it 5.89. Okay, so yeah. And what about this one? 45.895. Okay. Now my third digit is 5. It's neither greater than 5 nor smaller than 5. It's 5 itself. So what should I do? At that time, you take a look at the second digit again. If my second digit is odd, I add 1 to it. If my second digit is even, I keep it the same. What is 9? Is it even or odd? Exactly, it's odd. So that's why I add 1 to it. So 45.810. And because I don't need this 0 and this 0 doesn't have to do anything with me, I just keep it like this because the 0 doesn't have any value, right? We learned this in the previous lessons. So 45.81. And this is my answer. And this is basically what rounding off is. You just make the number easier. And less than 5 stays, more than 5 goes up, okay? And if it's exactly 5, we check the number before the 5, which if it is odd, we add 1 to it. If it's even, we keep it completely the same. And we're done. Thank you for being with me. If you've got any question, feel free to ask in our Discord channel sources page.